Now let's do one for a mean. Let's suppose that the final exam scores in statistics were 72, 89, 93, 65, 96, 92, 89, and 84. For a sample of 1, 2, 3, 4, 5, 6, 7, of 8 students from my large class of 200. So a little sample out of the whole class instead of everybody. What is a 95% confidence interval for the average score of all students? Yeah, that's a great question, right? Instead of having to take everybody, I could just take the average of these 8 students, but that would only be a point estimate to the truth, because it's not all 200 students. So, go into our class again, and the hypothesis, not the hypothesis test, sorry, the confidence interval first would be from here. So, come in here, and in order to run this browser, or run this applet, I'm going to first delete all of the data that he has in there, and then I'm going to insert my data one by one. 72, 89, 89, 93. For this applet, you put the data in different rows instead of with commas. So 72, 89, 93, 65, 96, 92, 65, 96, 92. Should be 2 more pieces of data. 89 and 84. 84. Okay, for us, sample range, we're going to keep blank, and confidence interval, we wanted 95%. The null hypothesis so far is not useful for us. It doesn't have any kind of meaning for our test. So I'm just going to compute this. And the confidence interval is the two-sided one, is the one that we want. It's between 75.86 and 94.14 with 2 decimal places of accuracy. So I am 95% confident that the average score for the class is somewhere between 75.86 and 94.14. Right? So what if I wanted to test a hypothesis to determine if my class is passing above 75%? As above 75% average on the exam. So in this case, the null hypothesis would be that the mean, or the mu we usually use, is equal to 75. And we're hoping to test an alternative hypothesis, which will have a mean that is bigger than 75, because that would mean people have above 75. So to test this out, I'm going to go over to the new one I found for you for testing a hypothesis on a population mean is different than a given mean. So I'm going to use this one again. I have 2 different options for this one I showed you, but I'm using this one because I already put the data in there, so it's already defaulted, so I don't need to rewrite it in. We are doing a one-sided, and we're trying to see if it was greater than the null hypothesis, which was 75, and the confidence level, let's say 95%. We'll reject it at 5% level again. So if we compute this time, greater, and oh, there's my p-value. So my p-value this time is 0.0180, which means that if the average of the class were 75%, then the chance that I had a sample of 8 with an average that I had would only occur 1.8% of the time. This is rare. That's less than our standard 5% cutoff level. So my conclusion is I am going to reject my H naught. I'm going to say I have evidence that my class does, on average, have an average score that is above 75%. Okay, hope this helps a little.